Good afternoon, ladies and gentlemen, and good morning, and welcome to our today's free webinar. Graphene nanotubes, a sustainable way to add electrical conductivity to your industrial coatings. This is our webinar today, and this is sponsored and presented by Oxiel. My name is Detlef Sassenberg, European Coating Scientific Consultant, and I will guide you through today's online event. So what we will hear in our webcast today, and we will hear about how to discover that graphene nanotubes unlock new opportunities and allow producers to combine a wide range of properties in industrial ESD coatings, including stable conductivity, high surface quality, good mechanical performance, and a variable thickness of coatings. Market cases of replacing standard additives with graphene nanotubes, reasons, and the integration process will be presented. But before we start, just a hint regarding our discussion. On your screen, you can find a box for your questions to our speaker. Please type your questions or comments into this box at any time during the presentation. I collect the questions so that we can discuss them with our speaker after the complete presentation and offer you an answer directly as possible. So, but now some words about our speaker. So we have Andrei Dubrovsky, Technical Manager for Coatings and Thermoplastics EMEA. So welcome, Andrei.
Dear Detlef, good morning.
Hey,
do you hear me? Can you see me?
Yes, perfectly, Andrei, perfectly. So this seems to be a large office you are in at Oxiel, right?
Yes, actually right now I'm in a business trip, and our partner very kindly assisted to me to organize this let's say participation in your webinar. So currently I'm not in our headquarters, but I'm extremely glad to participate, to have this opportunity to present our solution, and thanks a lot for the attention of our audience.
Yeah, we always a very interested and very expert audience. I can tell you, it's really fun to do that here. And of course, as a technical sales manager, Andrei, you should be not always sitting in your office, of course. That's right. But you know, let's talk a little bit about your background. So, what drives you to be working with this very new technology of material? So I have to say that you have a degree in mathematics and physics at the Moscow Institute for Physics and Technology, and then a diploma in economics at the Russian Presidential Academy of National Economy. Andrei, please, where was the kick for you to take care, and especially for the coatings industry? So that's interesting to know.
Thank you, Detlef. I'm a bit surprised about your awareness of all details of my history and background. So first of all, honestly speaking, in Moscow Institute of Physics and Technology, we had to use some specific books in which we had some exercises and some limits for the time which we need to spend for our homework, for the lectures, seminars, and etc., etc. So if you will calculate all the hours which you, according to this book, need to spend on your study, you will understand that in your day you should have 32 hours instead of 24. So one of the main competencies which I got there was, of course, ability to quickly understand what I'm required to do, and of course, technical background. So I was looking for a job. I was looking for opportunities for me where I can apply in the same time my technical background, my let's say communication skills, and where I can where I have ability to learn new. And in Oxel, indeed, we are growing. We are developing new applications. If you will compare Oxel today and Oxel 3 or 4 years ago, we are extremely another company, I would say. I mean, we have much more understanding. We have much more experience in industrial coatings, actually, and that's why we decided, thanks to you, thanks to your assistance and help, also to organize this webinar. So I will be extremely happy to share our experience and to tell more our audience about our products and approaches we are using today to implement single-wall carbon nanotubes into industrial coatings.
Yeah, perfect, Andre. It's good to have someone with this experience in physics and mathematics on board here in our coatings industry. So probably we have precise measurement and clear calculation now. And of course, this is very helpful to understand how your product is working. And we don't want to keep the audience longer on tension here. So now the audience is you, and everybody's keen to listen to your presentation, Andre. Let's go ahead. Come on.
Thanks a lot. Thanks a lot. So first of all, the screen is shared. You see presentation in full screen mode and everything is okay. Okay, perfect. Then I will continue. Dear colleagues, good afternoon once again. Greetings. My name is Andrew Dubrovsky. I'm Technical Sales and Business Development Manager at Oxel Europe. I have 5 years of experience of implementation of single-wall carbon nanotubes into production processes of electrically conductive industrial coatings at different facilities. And the majority of the companies with whom I'm working right now has one common intention to develop a new product with better properties, decreased carbon footprint, and extended durability. So let's have a look on single-wall carbon nanotubes, try to find benefits of this material in terms of final performance, and prove that this is the best electrically conductive agent from sustainability point of view. For the base of our study, I suggest to take 4 different types of industrial coatings, which has its own unique specifics. First of all, tank lining. This type of coatings should have high chemical resistance and provide excellent anti-corrosion protection. Secondly, we will consider ESD flooring with high abrasion resistance and good aesthetic properties. Thirdly, we will talk about conductive automotive primers used for electrostatic painting in automotive area. And these primers, of course, should provide a very high adhesion and transfer efficiency of the base coat. And last but not the least, the 4th application will be powder coatings with good surface quality and completely different production process. To bring electrical conductivity to mentioned coatings, you can use 3 conventional fillers. First of all, carbon black, secondly, conductive mica, and thirdly, single-wall carbon nanotubes. So to be objective and fair, let's choose 7 main parameters which we will use for comparison of performance of these conductive fillers. Point number 1, dosage resistivity ratio. Point number 2, maintained mechanical properties, ability of the filler to negatively or positively influence on mechanical properties. Point number 3, various colors, ability to produce colored coatings. Point number 4, complexity of processing, how it's easy to work with a filler. Point number 5, stable chemical resistance. Point number 6, economical aspects, cost per set of properties. And point number 7, of course, sustainability. So moving forward, I would like to tell a couple of words about single-wall carbon nanotubes itself. So single-wall carbon nanotubes or graphene nanotubes, which have a trade name tube-wall, are tubes with a wall thickness of a single atom of carbon. A diameter is about 1.2 nanometers and length about 5 microns. This material has extremely high aspect ratio, which is a ratio between length to diameter, which lead to unique performance of graphene nanotubes because they are very flexible. And this is one of the strongest materials on Earth with high conductivity. Graphene nanotubes, as I highlighted, are very flexible. And in case of homogeneous dispersion, they provide ability to influence not only the electrical conductivity, but also increase mechanical properties. So graphene nanotubes allow us to create completely new materials with a full range of required properties demanded from the market. And now, let's explore which specific properties single-wall carbon nanotubes can bring to industrial coatings and why they are better than any other antistatic additive. So, coming back to the final applications, I would like to start with tank lining coatings. Many companies already validated two-ball carbon nanotubes, and here is just one of the examples where 30% of conductive mica were substituted with just 0.03 weight% of single-wall carbon nanotubes. This tiny amount is enough to provide stable and permanent electrical conductivity and very good mechanical properties. But also, the next point is color. Color is a huge advantage for this type of coatings for two reasons. First of all, many servicing companies today require tank lining coatings in two colors. For example, dark and light gray, or dark brown and light brown. You can ask me why. Because they can easier and more properly control the thickness of the coating during application. Just imagine the specialist of servicing company may apply black layer and then light one, and in the areas where there is a contrast between them, specialist very quickly recognizes not appropriate thickness of the layers, and it helps to save a lot of time during application. And the second reason, after some time, it will be much easier to inspect defects at internal surface of tank lining coatings if it's light. Also, of course, the cleanliness of the tank will be much easier to inspect if tank lining coatings is light. But besides that, two-ball allow to cover full range of requirements, which we see today on the market. For example, only 0.02, 0.05 weight% of two-ball carbon nanotubes will be able to cover 10 to 4, 10 to 11 or multiply centimeter volume resistivity and surface resistivity. And electrical conductivity as a property will live as long as your tank lining coating lives. We provide permanent properties which don't depend on environmental conditions like UV radiation or humidity. Graphene nanotubes, in contrast to traditional conductive agents, maintain mechanical properties of the original non-conductive epoxy coating, resulting in a high level of durability and in a prolonged service life. As I highlighted before, our two-ball carbon nanotubes are very flexible, and due to the low working dosage, they perform very well in terms of adhesion, impact, and crack resistance tests. But the most important for this kind of protective coatings, our single-wall carbon nanotubes bring electrical conductivity, maintain mechanical properties, but also maintain chemical resistance of the base formulation. A specific industrial immersion test was done successfully. So tank lining coatings with two-ball have passed tests for crude oil, gasoline, ethanol, and of course water. Besides tank lining coatings, there are another type of coatings where mechanical properties and chemical resistance are also important. Of course, it is ESD flooring. So currently, more than 70 companies already validated our products for this application, and there are a lot of reasons why. First of all, carbon nanotubes allow to achieve required level of resistivity according to all existing standards relevant for European market, American market, and Asian market. Stable electrically conductive properties without hot spots and good aesthetical properties are highly welcomed by our customers. Due to the low working dosage of graphene nanotubes, it will be possible to produce colored coatings. And at these two charts, you can see dependence of volume resistivity, surface to ground resistivity from the working dosage of two-ball. And in the same time, dependence of color in terms of RAL shades. So just an addition of tiny amount of titanium dioxide or some another pigments can bring you light colors, and in the same time give you ability to produce static dissipative or even conductive formulations. And let's compare single-wall carbon nanotubes with conventional electrically conductive fillers available on the market. One of them is, of course, chopped carbon fibers. It is a very well-known agent. but it still has some drawbacks. First one is the limitation of base coat thickness. Generally, due to technology and average length of chopped carbon fibers, the base coat thickness is around 2 millimeters, because you need to orient chopped carbon fibers, and this is the main limitation. Also, the usage of chopped carbon fibers can be quite sensitive, and in many cases can lead to hot spots, which is flooring area with insufficient level of resistivity and some black dot spots on the surface, which is not very good for aesthetic properties. And if you damage some anti-static flooring with chopped carbon fiber, there is a high risk that you can lose the required property as well. I can tell you the short story which I have faced in my own experience. Our customer produced a top coating with our single wall carbon nanotubes inside, and they sold this formulation to their customer, which was a servicing company, the company which was applying this top coating. And then after the application, the end customer asked external laboratory to test surface to ground resistance. And then they have observed that there is no conductivity. Surface to ground resistivity was extremely bad. And then our customer, of course, approached Oxel and asked, "Okay, Andrew, how we can solve it? Why? Because we have seen everything working in a laboratory and at another production facilities." So we arrived to this location and we tested surface to surface resistivity, and it was extremely well. So when we started to investigate, it was pretty clear then that the servicing company, which was making application of the top coating, were using conductive primer, which was actually non-conductive. So it was the Cooper tape, non-conductive primer, and conductive top coating. And of course, our customer was extremely happy because we saved them a lot of money and nervous cells, I would say. So in this case, we can even assist in such kind of cases where there is a risk of non-professional application, because you can fully understand if the top coating would be, in this case, with chopped carbon fibers and non-conductive primer, that even surface to surface conductivity, it would have never been possible to observe. So single wall carbon nanotubes provide very good conductivity in all dimensions and gives opportunity to produce top coatings with thickness even lower than 2 millimeters. 1.5 is more than possible. We can also give ability to repair very easily the top coatings with the carbon nanotubes inside, with tubule inside, because, for example, in case of chopped carbon fibers, you need to cut top layer and apply the top coating again, because you're required to orient fibers. In our case, you don't need to do it. We provide a very homogeneous conductivity in all dimensions, so you just need to make some small abrasion processing to increase the active surface and apply the same paint you was applying in the beginning. You don't need to cut the top layer. Then the next point is that the level of conductivity sometimes, in case of conductive, I'm talking about conductive range, in case of conductive range, the level of conductivity of top coating is good enough, is so high that you don't need to apply primers. I can tell you that many of my customers, in case of not very huge working surface area, they are even not using primer, and also they are applying the Cooper tape only at the perimeter of the object. So this, of course, helps to have some additional benefits from economical point of view, because you use less material, you use less resources, and this is much more sustainable solution. And what is also important, that today many companies, I believe your customers as well, pay attention not only for the tests of surface to surface conductivity or surface to ground conductivity, but also to so-called body voltage generation test. And this is the pure feedback from our customers. We have received this feedback many times. We know that with our single wall carbon nanotubes, it will be much easier to satisfy requirements for this body voltage generation test, and the higher level of generation might be something like 10 or 20 volts. So this is very good. And let's also compare a single wall carbon nanotubes with another commonly used conductive additive, which is conductive mica, or different similar alternatives like conductive ATO. It is a stable industrial solution which don't have any mentioned issues with chopped carbon fibers, but at the same time the working dosage of conductive mica is relatively high, and the cost performance is much higher than required. So such additive can bring some additional limitation to your flooring business. With graphene nanotubes with tubol, working dosage and the cost performance is much better, and this leads, of course, to some additional cost reductions, which I mentioned before. So for flooring area, it's a sustainable solution. And let's move forward. There are a lot of different applications. The next one is conductive primer with a very low surface resistance, which is required for high transfer efficiency of the base coat. And here is it is crucial to provide excellent adhesion of the base non-conductive primer to substrate, and we can do it. Tubol allows to maintain mechanical properties and provide the most commonly used 500 kiloohms per square. In this application, single wall carbon nanotubes also give ability to produce colored primers. On the slide, you can see dependence of resistivity from dosage, and also possible colors which you can achieve. At the main working dosages of tubol, you can reach L value between 67–75%, which is a very nice level. And this is extremely important, because if we will apply the same thickness of the base coat on the samples, on the same substrates which were painted with black primer and with a light gray primer, we will see differences in the final L value. And this is important because we can decrease the consumption of base coat and reduce the costs for the wall formulation. What is crucial to add that today it is possible to create conductive primer not only for polypropylene substrates, for example, polypropylene bumpers or trims or other exterior parts, but also for SMC exterior parts. And the initial trials has shown that it is even might be possible to assemble SMC part coated with the primer, assemble it with the metal body and paint it at the conveyor. So we have such ongoing project, and if you are interested, we'll be extremely happy to discuss it more precisely separately. Single wall carbon nanotubes provide very good conductivity of the primer, which performs extremely well in terms of transfer efficiency. At the slide, you can see that even in comparison with the steel, transfer efficiency is very high. Last but not the least application are powder coatings, and here we provide ability to produce different types of powder coatings with different texture, for example, sandy texture or smooth texture, and also to cover two ranges of conductivity: static dissipative powder coatings and as well conductive powder coatings, with of course ability to produce colored solutions. And what is important to mention as well, I can tell you that many of our customers tested before carbon black. Of course, this is a cheap solution. And if they would like to produce a conductive coating, they are required to use rather high level of carbon black. And sometimes it was not possible for them even to extrude this material due to the high viscosity. And in our case, the dosages are so small, then we don't have such negative influence on viscosity during the extrusion. So from at industrial lines, there is no problems, and this is a very, very stable solution. And also the second, at the second chart, you can see the percolation curve. It is required to use just 0.01, 0.04 weight% of single wall carbon nanotubes in the final formulation to cover the full range of electrically conductive or static dissipative coatings. And due to the unique morphology and flexibility of single wall carbon nanotubes, we maintain adhesion, we maintain impact resistance, and we maintain resistance to cracking. So in general, mechanical properties are maintained, which is extremely important. We just add electrical conductivity as an additional property without any other changes. And let's sum up some general advantages of two-ball carbon nanotubes. First of all, it is easy to work with them. It is easy to work with single wall carbon nanotubes. To be honest, you even don't need to disperse pure single wall carbon nanotubes at all, because you will get from our site a tubal matrix. We produce a concentrates which are a pre-dispersed two-ball carbon nanotubes in some carriers. And these additives usually contain only 10% of carbon nanotubes and 90% of the carrier, which is compatible with your type of formulation. Currently, we have a lot of projects, and all of these projects, of course, are unique. Sometimes they have their own specific. So we have developed a huge portfolio of products which is compatible with solvent-free, solvent-based, water-based coatings, which are compatible with different types of the binder: epoxy, polyester, vinyl ester, phenolic, acrylic, and so on. So we have also implemented, of course, quality control management system according to different ISO standards, but also we have implemented quality control management system according to IATF standards, which are highly welcomed in automotive industry. So we pay huge attention to quality, and we are completely sure that everything which is presented on this slide and other products as well will be with a higher quality. Secondly, what I would like to mention is that today it's easy to work with our concentrates. It's easy to do. And you just need to proceed with your existing processing conditions: premixing, extrusion, cooling, milling, seeding, and packaging. Nothing special. And if we're talking, of course, about liquid systems like primers, ESD flooring systems, or other type of liquid coatings, there are several options. The most commonly used type of equipment is just a high-speed mixer dissolver. Nothing special. We can provide you with full technical support from our site. We can tell you all details, which type of blade we recommend, which level of peripheral speed at the edge of the blade we recommend to provide better dispersion quality, at which stages we recommend to dilute and to add our additives, and all other technical details. So we have a huge experience in this area, and we will be extremely happy to share this experience with you entirely. And thirdly, of course, the most important is performance. So currently, single wall carbon nanotubes give ability to cover a huge range of electrically conductive requirements. We don't have negative influence on mechanical properties. Moreover, we maintain them. We give ability to produce colored coatings. The working dosages of our material so small that you need to operate with an extremely low amount of our concentrates, so it's easy to store them and to ship them. And the most important, of course, are economical aspects. So today we are competitive. Today, single wall carbon nanotubes, it's not something which only, I don't know, NASA can afford themselves to proceed. No, today our products are competitive, and we can cover the full range of required properties demanded by the market. Looking for the low working dosage, of course, it speaks for itself. So less raw material is needed to create more high performance products. And furthermore, there is also a reason why it leads to a reduced energy consumption comparing to other antistatic engines. Depending on the project, it will be emitted less CO2 for modification of the same type of ESD industrial coating in case you use two-ball graphene nanotubes in comparison with any other conventional conductive materials. And finally, Tubal graphene nanotubes increases the life cycle and durability of a product due to nanotubes' ability to maintain or even improve mechanical properties of the base polymer matrix. We are confident that we can make your products better and help you to create more sustainable solutions. Please feel free to ask your questions here, or please feel free to send your questions at our corporate email, webinar@oxel.com. We will be extremely happy to support you and proceed all together closely. Thanks a lot for your attention, and I will be happy to answer your questions.
Well, Andrei, can I say спасибо?
Oh, great. Большое пожалуйста.
Thank you very much. And,
bitte schön.
Yeah, danke. Thank you very much for this presentation. And as it could be expected, we have technology, we have mathematics, we have exact measurement in physics, and what I really appreciate is your openness in commercial questions, because this is popped up here very frequently in the questions that, of course, it is a question of commercial attractiveness and to see, but I don't want to ruin your sales position here. So I think this price discussion we do personally.
We have strong sales position. We are ready to discuss a project on project base. No worries.
Certainly, it could be expected. But the most question is, could this presentation, is that available? Yes, this is. You can download that from the website. Again, no, we don't have that openness. We don't find this openness of companies in every time here, but I thank you very much for that, because you know that, of course, is that what the audience is interested in, to follow up and read that what you are excellently presented here, and get a little bit deeper into the material. Okay, so the questions, for example, it was, we have questions concerning hydro storage tanks. I think this is also a question for the future, because maybe hydrogen will be a future fuel that we have to see, and of course it would be we would be much more than happy to handle that. And how much is the contribution of nanotubes then to handle that, for example, storage tanks and those kind of things?
Just to make the question more precise, you mean what will be the dosage of carbon nanotubes inside the final coating, or how much we sell for this application?
Yeah, it's a general question for application in hydro tanks. For storing hydro tanks means you have to store liquid hydrogen, and of course you have to transport that. So I think this would be also quite interesting for the future technologies that we have to face to substitute common fuels.
Of course, yes, we are extremely happy to proceed together with our partners. Currently, tank lining coatings, which are modified with the tubal matrix grades, with our concentrates, with our tubal carbon nanotubes inside, are mainly developed as an internal protective coatings for a huge reservoirs, for a big reservoir parks. And they are used as an internal protective coating, which is actually protecting the substrate, the steel, from corrosion, and as well, of course, providing ESD properties, so the protection from the electrostatic discharge. In case of mainly some explosive liquids like different kind of petroleum fuels, diesel, some acids, and etc. Frankly speaking, I would appreciate to discuss it more precisely, the requirements for the specific tank lining coating developed for hydrogen.
Okay, so this is always what we have, because the audience is worldwide and covers a lot of technologies from our experts, and it's very difficult to have specific answers here, but we again promised no question will get lost. We will transfer all question of the audience to you, Andrei, for certain. So of course it is quite, it is concentrated also on dispersion a little bit here. It means application of the nanotubes in the formulation and in the production of the coatings. you said already it's easy to incorporate. Is there any formulation additives or something needed to incorporate them, and how could be the distribution assured that this small amount of nanotubes is completely distributed in the coating, in the wet coating?
It's a very good question. There are a lot of methods. The most simple, I would say, method is to check the dispersion quality of tubal matrix in a neat resin via grindometer. So we recommend, if we are talking about liquid coatings, we recommend firstly, at the first stage, to disperse our concentrate in a neat resin, for example, in an epoxy resin. We can provide, of course, some specific regimes for mixing. They are not some, I mean, they are commonly used. We can just reassure with our customers that the regimes they are using are convenient for the good dispersion quality. So at the first stage, we recommend our customers to mix neat resin, for example, epoxy or polyester, whatever, with our tubal matrix in a dissolver for some time with some peripheral speed at the edge of the blade, for example, between 7 and 15 meters per second. And then at grindometer, we can see a grinding degree. And currently, what is very interesting, today, if we would like to achieve very good conductivity, we don't actually need to disperse single wall carbon nanotubes for the stage when all of them will be separated from each other, when all of them will be somehow suspended in the volume of the polymer. No, we need to disperse them in that way, which will lead us to electrically conductive network, chaotic 3D electrically conductive network. And currently, we recommend to disperse our products for the stage when our customers will see at grindometer the maximum sizes of agglomerates at the level of 15, maximum 20 microns. So these bundles are very effective. We observed it in many kinds of coatings, in many different applications, that this level of length of the bundles is a more convenient option for electrical conductivity. So grindometer is a very easy to handle equipment. I do believe 99% of professional producers of paints and coatings have it. So nothing special, very easy to control dispersion quality.
Okay, so sorry for the audience. It's not a disrespectful that I take a look left away from Andre and you, but the questions are here on my left side, and during our discussion, I try to collect the questions popping up, many at the moment here, to find out which could be in the general interest of the audience, because again, specific questions will be answered by Andre directly to you. And what I see is that under the lots of questions concerning the application of nanotubes in different type of coatings, so the crystallizing UV coatings is a question. So can you say how about, is there anything that is something specially about if you have systems that are UV curable and also transparent UV curable and transparent systems? This is also a question that comes frequently here.
Transparency depends on the thickness of the coating. I can tell you that we have some PSA applications where we can also consider them as a coating application. In this case, indeed, we can slightly decrease transparency, which is acceptable for our customers. In terms of UV curing, yes, of course, we are working in many different applications. We have different products. I can tell you that not only tubal matrix is our product, I mean, as a family, as a series of products, our portfolio is fulfilled also with some additional options like suspensions. We produce suspensions, waterborne, NMP-borne. We are developing different types of suspensions based at different solvents. We are happy to discuss it more precisely again, because sometimes our customers are using coatings with a low amount of binders and fillers and with high amount of actually solvents, or if it's waterborne coating, then water. And in this case, it makes sense to incorporate single wall carbon nanotubes, not via the binder, not to bring them inside the binder, but to substitute in the formulation some amount of solvent with our dispersion. It will be much easier to achieve good dispersion quality in the higher content in the biggest part, I would say, of the formulation, and then, of course, dilute it together with the binder and the fillers. So yes, we are working in this area. Yes, we have different products, and yes, we are able to discuss questions related to transparency. But if we are talking about some applications where the thickness of the coatings is more than, I don't know, 100 microns, 200 microns, then of course, single wall carbon nanotubes is a carbon-based material. We have an extremely developed surface area. We observe light very well. We cannot break the physics. If we're talking about the high thicknesses of the coatings, then yes, most likely the coating will be black if we don't modify it with titanium dioxide or with some other coloring pigments. Hope I answered the question.
Yeah, the question was more clear coating. If I understood the question right here, we're talking about also, you know, we have a lot of audit participants maybe that are working with clear coatings, and they also want to have this wonderful properties, physical properties of your nanotubes in clear coatings. The question is, does that affect clear coatings if you use that?
Mainly we are working with some industrial applications which I mentioned before. So clear coatings, of course, is an industrial application, but it's more for aesthetic properties, in my opinion. So of course we have projects, and yes, let's discuss them at projects based. What is the type of the binder? What is the type of the solvent? What is the requirements for transparency? What is the thickness of the coating? Which level of antistatic properties it's required to achieve? Because in any case, if we would like to provide antistatic properties for clear coat, we need to use a very small amount of single wall carbon nanotubes, a very small amount of tubol. And in this case, from physical point of view, the dosages will be so small that we might affect on electrical conductivity. We might bring antistatic properties, but these dosages will be too small to improve mechanical properties of the clear coat. But I would like to highlight that today we have in our R&D plan also projects related to mechanical reinforcement of the top coatings. I would say not clear coats, but top coatings. It's a separate story. We will be happy to discuss it separately.
So one general aspect in the questions here for all in the auditorium is health and safety. So is there a word, because the word nano triggers,
yes,
of course,
definitely.
some concerns, because this is of course an overall question, I think, for all the participants here in the audience.
Thanks for the question. First of all, yes, I just realized that I have not yet mentioned in a presentation. Point number one, we are REACH registered. So we have no problems with the sales of our product in the European Union and other countries. Point number two, we are producing concentrates, which are a polymer, a carrier, in which we disperse single wall carbon nanotubes. So the product which our customers are receiving today is some kind of a polymer. It's tubol carbon nanotubes cannot release out of this product, so they should not be afraid of any kind of release of single wall carbon nanotubes as a single nanoparticle out of this product. This is point number 2. It's about processing and work with our concentrates. Point number 3, this is extremely important, and we have paid a lot of attention and resources for an external tests. We have done, and we are happy and we are ready to share this knowledge, to share the results of this research. It was an external institute which tested thermoplastic panels with carbon nanotubes, with our carbon nanotubes inside. They tested as well epoxy-based, if I'm not mistaken, coatings. It were the panels with the coating with our carbon nanotubes inside. And it was as well elastomers with our carbon nanotubes inside. And there were some specific tests like drilling and abrasion. And then this institute was evaluating amount of single wall carbon nanotubes as a single nanoparticles which were released to atmosphere. And the results are very interesting. There is no single wall carbon nanotubes which went out of the polymer. Of course, they absorbed the particles of the polymer itself at macro sizes, but all carbon nanotubes were binded with the polymer. It was not they didn't they didn't absorb any single wall carbon nanotubes as a nanoparticle separately in the atmosphere. So in this case, we can tell that even products with single wall carbon nanotubes are safe in this in this point of view.
Okay, so what can I say? Yeah, there's a few more questions here, but I think that is more or less specific, addressed to you. And Andrei, I'm very sure that our participants who have these questions will receive an answer on that. And my impression is, Andrei, that it's not the last time that we hear from you about your products. I'm very sure. So thank you very much again for this perfect presentation. Thank you for this very interesting product. Gives them lots of ideas at coating chemists sitting in their labs and trying to do hard work for the best of their customers, finding solutions. And maybe this is something where they can find solutions here. So again, thank you very much. For you, Andrei, I wish you a safe onward journey. And with your product, a very successful onward journey. And of course, to our audience, I would like to thank you again for your participation. And what we have to say now is take care and all the best. And the most important is stay healthy, and probably we'll meet us again in the next webinar, probably also again on nanotubes on Andrei again. So that would be very much fun, I believe. So thank you very much. All the best for you. Again, take care and yeah, stay healthy. This is the most important thing at the moment. Thank you very much, and bye-bye, Andrei. Goodbye.
Thanks a lot. Bye-bye. Bye.
Bye-bye.